Everyone. Recording is now in progress. Good morning. Welcome to the third session of our Nature Inclusive Design webinar series. In this occasion, we will bring you representatives from Red Eléctrica, the transmission system operator in Spain, to present how subsea grids can support marine biodiversity with the use of a material called Biorock or Xerock. My name is Denis Aguilar Bellamy, coordinator of the Offshore Energy and Nature team at the Renewables Grid Initiative. So before we start, and while letting people in, a couple of house rules. First of all, please put your cameras on when the discussion is ongoing. The mics should be off. If you can, please rename yourself to name an organization so we can know who you are and who you are representing. If you have any questions, please raise your virtual hand. I'm going to be keeping track, and there's going to be a Q&A at the end. So then I'm going to give you the floor when it's time. This webinar is being recorded and will appear on the RGI and offshore and ocean websites afterwards, in case you want to share the link as well. We will also be sharing the PPT. So, first of all, a little bit about our organization, the Renewables Grid Initiative. We are RGI, a collaboration between transmission system operators and environmental and climate NGOs from across Europe. We promote the development of environmentally sound grid infrastructure to enable the integration of renewables. You will see the website in the chat right now. Now, with this same spirit of collaboration, a few years ago in 2020, the Offshore Coalition for Energy and Nature, OCEAN, was established, with RGI acting as the convener and the moderator of this group. Today, the coalition has 23 organizations, including transmission system operators, NGOs, but also the wind industries, who join forces to collaborate on the deployment of offshore renewable infrastructure hand in hand with the environmental protection. Now, more recently, just last month, on the 28th of September, we officially launched the Mediterranean branch, MedOcean, extending our collaboration in the southern basins. And MedOcean brings together, for now, 14 organizations, including Red Eléctrica. So this is actually the first webinar in the context of MedOcean. Important to mention, what is nature inclusive design? What are we organizing this webinar series? So one of the solutions identified by OCEAN members to reconcile energy and nature is the application of nature inclusive design solutions. In our discussion paper, OCEAN's discussion paper on essential environmental concepts, we use a definition from Hermans that refers to NID as options that can be integrated in or added to the design of an anthropogenic structure with the aim to enhance ecological functioning. So in this occasion, this design is going to be about Biorock or ECOncrete. We have organized I believe three webinars so far within this series. If you want to know more, my colleagues are going to be sharing the link of previous versions. And without further ado, I would like to introduce our speakers for today. First, we will have a presentation from Roberto Cabrín Garcia. He's a marine biologist at the Environmental Department of Red Eléctrica. So he is going to start with his presentation, and this will be followed by the contributions from Yaeli Rosenberg, who is the head of biology at ECOncrete, the organization that actually is implementing this material, Biorock, the technology, in collaboration with Red Eléctrica de España. After the presentations, we're going to be opening the floor for questions and answers and a discussion as well. So we are very excited to have you both here. Thank you so much for your time and for introducing this super exciting technology. So we want to know everything about it. What is it about? Where is it being implemented? How can it be applied somewhere else? So Roberto, the floor is yours. I'm going to stop sharing my screen and then you can share your slides.
Can you see my screen? Yes, good.
Yes, we can, no problem.
Okay. Okay. Welcome, everybody. It's a pleasure for me to share our knowledge and experience with underwater cables with you. And in this webinar, I would like to share with you some details about underwater cable projects. We are going to talk about how we can support marine life in our projects. I would like to start with a presentation about Red Eléctrica, just a few words to understand who we are and what we do. Red Eléctrica is the Spanish TSO. That means that we transport the energy and we operate the electric system. At TSO, we work to ensure the correct functioning of the Spanish electrical system and guarantee at all times the continuity and security of the electricity supply. We have to guarantee that the energy production and the demand are in balance. For this work, Red Eléctrica is the owner of the national transport grid that is closed at 45 kilometers. And in this grid, we have more or less 1,400 kilometers of underwater cables. Why we have all of these underwater cables? Because we have to connect our isolated lands as Balearic Islands that you have here, Canary Island, and as well we have some international connection with Biorock, and we are working now with friends for a new interconnection. Just few details, we have actually 9 underwater interconnection, where the longer and deeper is between Peninsula and Mallorca, with 237 kilometers length and with a maximum depth of 1,040 meters deep. That is a lot. Before 20 in one of our projects, I would like to explain you some small details that what we need to develop underwater cable, because it's an amazing world that not everybody knows, and just a few details to understand what this type of projects require. The first of all that we need is to develop a lot of different studies. We start with some desktop studies to analyze the information that are available in different databases. These studies should help us to improve our knowledge and to focus in a better way our marine campaign designs, because we need to do a lot of different marine campaigns to take information from marine environment. For example, we need to take knowledge about the environmental aspects that can offer us some restrictions, because, for example, we need to protect or to avoid the impacts some sensitive marine habitats. As well, we need to do some geophysical and geotechnical marine campaigns to understand some natural restrictions that we can have to lay a cable. Imagine that if we have a really high slope, maybe we are not able to lay the cable, and maybe we have to assume some risk for the cable that we need to avoid. Finally, with these all studies, we have a photo from our marine environment. And in this marine environment, we can design our corridor where we could be able to lay a cable. This is just one example where you can see the bathymetry, all the environmental information, and you can see how we can define one of the corridors to lay a cable. After these all studies, we have to consider the building phase. And we have one phase that is really important, because the land-marine interface, we have to consider how we can manage the different impacts. For this interface, we used to consider 2 options. One is the typical open trench. You open a trench in the coastline, but this practice has some problems because the works are complex, used to have more social and environmental impacts. For these reasons, we used to consider as better option the horizontal drilling, directional drillings, because with this practice, we are able to avoid the impacts in bits that are really important for tourists, for all of us that we love to go to our beaches. And finally, we can be able to protect the habitats, because in the coastline, we used to have a lot of marine habitats that are protected and they are really sensitive. And this technical, with this technical, we are able to avoid this type of impacts. The other step for this project is the cable laying. The most common restriction for this activity is that we only have some companies around the world that are able to do this practice. as well that we have just few companies, we have the same problem with vessels because some companies just have one vessel or two. We don't have a lot of vessels to do this type of works, and they need a specific type of vessels with a specific type of crops, remote operate vehicles that are able to lay the cables with security. To lay the cable, we need to protect the cables for the external aggressions because we have some activities, human activities that can cut the cables, and we don't need this. We need to protect it. For example, these activities could be a trolling or anchoring that can cut the cable. To protect the cables, we use specific rocks that we use in base of the type of the sea bottom that we have. We use jetting for poorly consolidated sandy material that is just pieces of water jet. We can use in this type of sediments as well, plugging that is just like a plug. And when we have hard or rock materials, we use trenching. That is just like a saw that cut the rock to get the trench. But sometimes we are not able to bury the cable as we want, and we need to use external protections to guarantee the cable protection. In this case, we use concrete matrices, cast iron seals, or rock placements to offer an extra protection that guarantee that the cable finally is really well protected. Okay, after this quick explanation about underwater cables, was very faster. I want to tell you about our first experience with nature positive solutions. We have this first experience in the connection between the Canary Island, Lanzarote and Fuerteventura. This interconnection is in outer current at 132 kilovolts. This project is boost of the decarbonization of the energy model in Canary Islands. Due to this interconnection, facilitates the integration of renewable energy in the system. The interconnection includes 2 submarine cables in outer current with a length of 14.5 kilometers and a maximum depth of 80 meters. We have as well 2 land routes, shorter land routes, because in Fuerteventura and Lanzarote we just need more routes. I would like to just to count how we decide to use the innovative solution to use a natural positive solution. When we start the construction, we detect some problems to achieve the target distance of one of the HDDs. This was due to the extremely hard rock that we have in Canary Island, because Canary Island have a volcanic origin. The rocks are basalt. The basalt is really hard rocks, and it's really complicated to drill this type of rocks, and as well it's really complicated to cut it. We analyze how we can get a trench, because we need to get a trench in 2 meters deep to 8 meters deep in a land of 150 meters. And we need to decide, because in these shallow waters, vessels can work because they are not able to work in these shallow waters, and we need to decide how we can do it. We update excavator for underwater operations to get this trench. Finally, we get this trench. You can see here the result of the trench that is with less than 1 meter width and less than 1 meter depth. We lay the cable inside the trench with cast iron shells to guarantee the cable protection, but it wasn't enough. We need something more, because we have the cable in this situation just in 2 meters. The cable is visible for everybody. We need something more to cover the trench. And in this case, our trusted consultant, they proposed us to talk with ECOncrete and use these new innovative solutions. ECOncrete proposed us to use the concrete blocks from the matrices to cover the trench, and we did it. You can see the results. After 10 months, we get a completely integrated marine environment of the concrete blocks. It's like the sea. Finally, the blocks mimic with the marine environment. Why? Because the microalgae grow over there with a similar species composition to the natural area around the cable. If you see the picture in the middle, you can detect practically these blocks are in the middle, but at the end you can see it, because we get a really good mimic. You see the pictures that we have in left and right. You can see in more detail how marine species group up in the concrete blocks, and the most important, that how other marine species like fish or crustaceans that are here and gasteropods are using these blocks as their home. We get two things that are really important for marine environment. We get to mimic the concrete blocks in the natural area, and we get that the species use this area as their home. This is really important things, because we get two things that are important to recover in marine life. With electrical, don't stop here. We know that the sea is our future. We know that we have more underwater cables to develop, but we know that we have to do at the same time that we develop our projects, we have to promote more action for marine restoration. Actually, we are working to find more of solutions as ECOncrete. We can use, for example, the ECOncrete solution for our matrices to improve the quality of our marine life. And we know that sometimes we're not able to do sometimes this type of practice, and we know that we have to mitigate our impacts. And for this reason, we are working close with the scientists to define some new restoration techniques. Some years ago, we have a project with Posidonia. That was an amazing project that offered us a lot of happiness. We get a restoration of 2 hectares with a survey of more than 90% of the fragments that we were putting on the sea. And actually, we're working as well in some projects, A+D, to reef restoration. But we want, in this case, use something different. We want to recover the discards of Gorgonia or corals that some human activities generates, as for example, fishing of our activities. And we are working in this line. For finishing my presentation, I would like to show you one video that we prepared for the RGA Awards this year, and where you can see better our practice with fish. Sounds amazing. I love it. Okay, and now Yaeli from ECOncrete is going to tell you how the technology is working.
Thank you so much, Roberto. This is really interesting. There's like really interesting pictures, and I have a lot of questions. I can see already in the chat that there's a few questions from participants. But because the next presentation is going to go a little bit more deeply into this technology, let's let Yaeli start her contributions, and then we will keep the Q&A at the end. So Yaeli, please, the floor is yours.
Hi, everyone. Can you see my screen?
Yeah, we can see it without problems.
Great. Thank you, Roberto. It was really fascinating presentation, and the Canary Island project of Red Eléctrica is a perfect example of ECOncrete's technology, and it really emphasizes the reason why ECOncrete was founded initially. It was founded in 2012 by 2 marine biologists, aiming to reduce the negative effects of coastal and marine infrastructure. We're a multidisciplinary science-based company where marine biologists, engineers, and designers work closely together to create nature-inclusive design solutions. We've been collecting marine biodiversity data for over 10 years with our aim towards enabling a responsible marine construction. to fully understand our technology, you need to understand first how marine settlement works in nature. I'm using a really simplified diagram just to set the foundation for our technology and give an example of the critical stages in marine growth. Basically, marine organism larvae, such as corals, they float in the water column, searching for an adequate substrate for settlement. When the larvae senses the right chemical and physical cues, they will settle and start secreting their attachment filaments or skeleton onto the structure itself. Finding the right substrate has a very strong implication for the survival of those organisms. For that attachment to be strong enough to resist ocean currents and waves, and also allow the organism to grow, the substrate should be complex to fit many different sizes and forms of life. Together with texture and material, there's organisms with different habitat preferences. Finding the right niche for accumulation will also determine the survival and the continuity of that organism and the community. Corals, for example, prefer areas with high water flow and direct sunlight for their endosymbiotic algae. Some sponges settle in darker areas like caves or overhangs, and tidal species like barnacles or limpets settle on high grounds where they sense the tidal amplitude. So each organism finds its ecological niche for settlement and also growth. ECOncrete technology was designed to incorporate as many of these principles to enable the successful settlement and survival. We aimed at optimizing marine infrastructure by changing the chemical composition of concrete to reduce the negative effect on larvae settlement. We increased the surface complexity to support the attachment of different organisms to the structure and create adequate habitats to cover the entire life cycle needs of many organisms, both sessile that attach to the structure like corals or barnacles, but also motile organisms that utilize the infrastructure like fish or crabs. Our technology not only enables species to grow and survive, but eventually it creates a flourishing ecosystem, supporting a wide range of food webs, restoring biodiversity and ecosystem services. Our solutions comply with the industry standards for manufacturing, installation, and structural performance. From the next few images, you can see how our core technology was leveraged as a nature-positive solution to restore the impacted habitat and biodiversity. By the images you saw and you'll see now, by integrating ECOncrete technology, the units were able to mimic the natural reef. You can see the naked concrete unit during installation. It's highly distinguished from the surrounding area. After only 10 months, the units are unnoticeable, completely integrated into the natural reef, where we see the same biological community accumulation. With this specific unique design, we were able to recreate the habitat features that were lost during trenching. Our offshore infrastructure enables the creation of an ecosystem that provides shelter for different species during vulnerable life stages like growth, reproduction, and feeding, altogether supporting the different lifestyles of many organisms. The habitat complexity is increasing with time due to the biological accumulation, with many different algae species that create shelter for many juvenile organisms. The lost biodiversity is actually restored to continue and provide multiple ecosystem services. The different ecological niches created by the units themselves provide species-specific habitats like caves or overhangs, which allow many organisms with different habitat preference to accumulate on the same structure itself. Each organism contributes to the ecosystem, starting from CO2 absorption to habitat formation to water filtration. Each one of these services is vital for the resiliency and the health of the ecosystem. The tailored unit that was used in the Canary Island project is actually part of a marine mattress design that we've been developing as an alternative solution for cable protection, as been highlighted by Roberto. We've applied our bioenhancing concrete technology to design an ecological marine mattress that by design prevents sedimentation, provides substrate and habitat, increases biodiversity, and minimizes the environmental impact of infrastructure. Our technology creates better conditions for biological enhancement while keeping the structural integrity of the solution. At the micro level, the unit's micro surface texture and bioenhancing properties are intended to facilitate higher colonization of sessile organisms, which together with the habitat complexity fit different life stages of many marine organisms. These mattresses improve habitat potential for local species and increase biodiversity and the biological function of the structure, but also its surrounding. Like other ECOncrete solutions, the mattress are produced with low carbon cement and manufactured locally to reduce greenhouse gas emissions. With our technology, we're developing a structural solution to help transform how needed infrastructure can become nature positive. As such, we need to achieve the same hydraulic stability to be compliant with engineering requirements. As part of our ongoing effort, we're testing the hydraulic stability of the mattresses at the University of Madrid. These 2D physical model will give us the hydraulic stability limits of these mattress units. This is another key example of how our solution can help unlock new opportunities for projects. In this case, the largest US offshore wind project, Vineyard Wind, received green light from regulators to install our ecological cable protection, while traditional concrete marine mattresses were forbidden in these eco-sensitive areas. These solutions, like the tailored unit for Red Eléctrica project or the marine mattress, we believe that more and more there will be a demand for nature-inclusive design solutions. We see there are more and more ecological criteria and tenders for offshore projects, and Subsea will see the same trend. We believe that solutions such as ours will be more and more needed. This is highlighted here by this recent statement from the Offshore Coalition for Energy and Nature, which is encouraging European member states to make full use of ecological non-price criteria for the design of offshore wind farm auctions. We believe we have this something unique. For example, we're also developing a scour protection unit, leveraging our technology. The technology can be leveraged to design any offshore structure to create biological enhancement as an integral part of the infrastructure at scale. This emphasizes how our approach and technology can be applied to any offshore and subsea infrastructure. Many of our projects are constantly monitored to improve our understanding of the synergistic effect our technology components have on the surrounding ecosystem. The drop lock, the scour protection unit, was deployed offshore Long Island in a pilot project, comparing the bioenhancing units to traditional rock armor. The project is being monitored using high-end techniques to understand the effect on the ecosystem from gene level to food web modeling. The Red Eléctrica project Roberto presented is an amazing opportunity to highlight the value proposition of our technology in terms of environmental impact. As we demonstrated throughout time, we're able to increase biodiversity, to reduce invasive species dominance, to recruit more inorganic biomass, and increase CO2 sequestration and water quality. This goes together with easing developers' struggle with permits and regulations, helping maintain stakeholder alignment, and applying for environmental risk mitigation. Thank you all for listening, and especially RGI and Red Eléctrica for having us join this webinar today.
Thank you so much, Yaeli, Roberto, for these presentations and for the introduction to this technology. I can see that there's a lot of questions coming in. I was expecting that, so I'm going to keep my questions for the end, and I will start giving the floor to our participants. So I would ask each one of you to actually ask your own questions. So be prepared to turn your camera on and to ask your question yourself. So I will start with Roberto from ECOncrete from the Irish TSO. Could you please turn on your camera and ask your question?
Good morning. Can you hear me?
Yeah, we hear you just fine.
Great. Yeah, excellent presentation. So ECOncrete is at the concept design stage at the moment, and by Christmas we will have specifications for a range of nature inclusive designs, and we're going through the design risk assessment. So just one or two questions. One specific question was around the risk of troll snag on any of the rough surfaces. Obviously, the introduction of rough surfaces, I understand, is very important for the colonization of these structures. Is there a legitimate concern there in terms of snagging fisheries gear, and should certain types of these structures be installed in certain restricted areas for fishing? Thank you.
Thanks, Roberto. You have the same views as our engineer department about the specific form of the concrete blocks. I would like to show you one picture, just because I think that is interesting that you see the size of the blocks. Okay, wait a moment. I don't know if you are seeing the picture.
Yeah,
we can see it, yes.
And these are the same images that I've shown to my engineers, or very similar.
Okay, you have to look the size of these forms, because if you compare this size with the size of the mesh hole of the fishing nets, it's not really easy that the net take the block and go away. I think that is not really easy, but we have the same rules. In our case, in this first experience, in the area in Canary Island, trawlers are not allowed, and we don't have this risk. Okay, and as well, we have the first experience is in 2 meters deep, 8 to 8 meters deep. It's not a typical area for trawlers, but our engineers have our same dude. We are discussing about that, and we are considering that maybe we can accept some modification for this type of blocks to mitigate or reduce the risks of the trawlers can take the blocks and go with them.
Thank you. So you're going to modify the specification, is that right?
Maybe we're analyzing. We're working with the concrete to talking about these type of things.
Okay. Thank you very much.
You're welcome.
For over-trawlability, we have tapered edges for the marine mattress, especially for that use. And of course, I mean, each area and project has a different design and different specification. So usually according to that, we work.
Sorry, so the tapered edge, is that already integrated into the specification Roberto is showing, or is that a new specification you're referring to with the tapered edge?
No,
the tapered edge is part of the marine mattress.
Yeah.
Those units composed together.
Okay, thank you.
Thank you, Roberto, for your question to the other Roberto. So we have a few more questions actually. Quentin, I think that you were next. Could you turn on your camera and ask your question?
Hello. Thank you very much for the presentation. Very interesting, guys. My first question is related to cable design and overheating. So, of course, the cables have electrical currents, there's resistance in it, and it will produce heat. Sometimes we might have some environmental limits on how much heat is allowed at the seabed level, or how much extra temperature we're allowed to have. Do you have any feedback already on this for the installed elements, or maybe for the design aspects? Do we know the thermal conductivity of these mattresses, and also the impact it might have on the habitability, if that's a word, on how good it works as a habitat?
About the heads, we have in this project, we install distributed temperature sensing that offer us the temperature of the cable along of the cable. We can check in all points, in AKP that we want, the temperature of the cable, okay? And we see that we don't have a great difference with the temperature of the sea. We can detect some small difference in base of the type of protection that we use for the cable, but it's not a really high difference with the sea temperature. It's really similar. We are working now to analyze this in more detail, but we don't have more heat for the cables.
Thanks a lot.
Hi. We're working on a cable protection stabilization system, and the cables already have a protection system that also helps isolate, and then the concrete is above them, and concrete is a good isolator. And in our technology, we use the standard concrete measurements that are needed in regulations.
Okay, perfect. Thank you very much. Maybe I'll jump to the next question I had.
Yes, please,
I have
Quentin.
the floor now. It's about the drop lock units that you want to use for scale protections. Currently, the way scale protections are installed offshore is via fault pipe vessels. So the elements, usually granite rocks from Norway, typically at least in the North Sea. These rocks are quite strong, and so they don't break so much. They are handled a lot, so they are produced in a quarry. They are displaced in the quarry itself, put on the vessel, and then on the vessel there's handling so that the rocks go through a pipe. Then they fall down from 10 to thousands of meters onto the seabed. How is the durability of these drop lock units? Do they break a lot during handling? And if so, does that also impair their ability to create a nice habitat?
So we've tested, we did a drop test for the drop lock. We installed them in the US offshore at 40 meters. We didn't notice many breaks, but we are doing tests right now with the main contractor on that. So they're designed to be implemented as rocks. I mean, use the same techniques as rocks.
And so we don't expect more blockages in the pipes, these kind of things, because I see that they are quite long elements with edges. So in one way that increases the stability offshore when it's installed, but maybe it's harder to install.
Yes, so we're testing. I mean, we're testing that and working with fault pipe vessels.
Okay. Thanks.
Thank you, Quentin. We're getting really good questions here. So the next one is from Liam from RGI, actually concerning the maintenance, because this is, I think, a question that a lot of us have. Liam, please ask your question.
Yeah, thanks, me, and thanks to both of you for those great presentations. I must admit, I don't know so much about marine cables. I mainly work on onshore work, and there when we work on vegetation management and creation of ecosystems underneath the grid, one of the concerns that grid operators have is about creating these wonderful, thriving ecosystems and then having to access the cables and then destroying the ecosystems. Is this a risk that these marine cables would need to be accessed? And if yes, how would you unlock the new ecosystems to access it without destroying them?
Normally, we don't need to do something with the cable underwater. It is normal. Sometimes we have some accidents, for example, for trawling activities, and we need to repair the cables. And in this case, we need to access to the cables, but this is not the normal. If we have some problem, we have to move it because we need to take the cable, because if not, finally the cable is not working, we don't get our expectations. But you can move it. For example, with the mattresses, you can take it out and take the cable. You can move I don't know if you understand that. Then I would like to show you that if you can remove the matrices to one side, and you can take the cable, you can work, and you can put again the cable, and you need to put the new matrices. And finally, you are going to do the same to recover the marine life, but you can get a few impact when you have to move it. But this minimized. Finally, when you introduce just this type of solution, you offer a better solution for the marine life. And if you have to move it, you have a less impact, but they are going to continue with the marine life.
Okay, that makes sense. So the matrices, the specific modules of a certain size, and if you need to access this one part of the cable, you would move this mattress to the side.
You say for our practice. In our practice, we're in few meters, 2 meters. We can take it with some specific elements because we need to take out. We can take the blocks out because we are working in 8 meters deep. It's not. We can work with divers. It's more accessible area that, if, for example, you have to work to 100 meters. It depends. In this case, we will be able to take out without risk, and we maintain all the marine life in the blocks.
Okay, great. Thank you. Thanks very much.
You're welcome.
Thank you, Liam. We have the next question is from another TSO from Tenet. Wen, would you like to ask your question?
Yes, thank you, Vinny. Yeah, I was wondering about the nature positive claim, because I do understand that this is really a beneficial measure compared to well, the regular way of working with normal concrete or whatever solution that is chosen. But compared to the original seabed, could you claim that this actually is a positive measure for nature?
Yeah, I understand your question. It's a complicated way we say neutral, positive. The good thing in this case is that where we don't used to do something to improve the quality of marine life, like with this type of practice, for example, when you use concrete matrices, we use typical mattress concretes that don't work for marine life. And in this case, we are doing something that can offer a new opportunity to marine life to cover it and offer us a good result. But I understand your question because it's just how you manage. It's not really easy. For someone is positive, for someone is neutral. But finally, the important, as I say in my presentation, is that we have the opportunity to do more things, because sometimes we have to do a trench, we do the trench, but we can do something more. Like our practice, you have something more to improve the quality of marine life. If not, you can leave just the trench. And with the trench, you don't do something more. And maybe you work to another area to do marine restoration, and you have to do something more active, more specific. But in this case, it's more passive because you introduce a new element that works to natural restoration. Because finally, this is nature who works to recovery, not us. We introduce an element and stop. But sometimes when we have to do a marine restoration, we have to spend a lot of time, a lot of resources, and it's more expensive, more complicated. It's different ways.
Yeah, still, I would argue that it's mitigation of your negative impacts, but it still is a good measure. Don't get me wrong, but
yeah, finally
we would call it mitigation.
It's another way to mitigate, exactly.
Yeah.
But we say that it's positive because you use the same infrastructure, but with something that offers you a plus. You finally get a plus that at the same time that we purchase the cable, we are able to improve the quality of marine life, and that then the macroalgae and the other habitats get a natural recovery.
Thank you.
You're welcome.
Excellent. Yaeli, you wanted to add to that, or we move to the next question?
Yes, please. I think the nature positive also, it's across time. I mean, slowly, it's integrated into the ecosystem, and it becomes part of the ecosystem instead of interfering the ecosystem itself. Like Roberto said, at least in ECOncrete, we believe in giving nature the opportunity to restore itself. We do not plant, we do not seed anything, but with time, we believe that we create and support the ecosystem.
Thank you both. Thank you, Gwen, for your question. We also have a couple more questions. So Ines Manchado, about the erosion, are you still there? Could you ask your question?
Yes. It's related with the fact that these deployments are considered to be in the sea for a life cycle of about 20 years or between 10 and 20. Do you foresee that the erosion rate of the material withstands this period of time, or would it be necessary to replace in a certain period of time? It's just technical curiosity here. Thank you for your presentation also.
So Roberto, would you like to start?
I think that is one question for Yaeli, but I think that these infrastructures with the natural cover, they don't have, they are able to stay a long time. Finally, with the carbonato calcico, I don't know the English name, sorry, the carbonate calcium for calcium cover all the infrastructures, and this offer the stability for a long time, and we don't need to replace it. I think that is the way that we don't need it, because finally the natural cover offers the guarantee of the air maintenance a long time.
Also, I mean, our technology complies with concrete standards, so it has a minimum design life of 50 years. So it's definitely there for a long time.
Thank you.
Thank you, Ines. Batol, I think that you have a couple of questions in the chat. Would you like to turn on your camera and ask them yourself?
Hello, thank you for your presentation. I would like to know that this type of ECOncrete has a biodiversity aspect, but for the other options, for example, if we want to compare them as a CO2 footprint with a natural rock, or as a cost or as an installation, is there another advantage for this type of the ECOncrete? For example, if you want to cover the trench with the natural rock, what's the advantage of ECOncrete if we compare it with natural rock?
So regarding the costing, it needs to be analyzed, and usually it's by project, case to case. The CO2 emissions, so they're produced locally, so there's no transmission. There's no transportation emission.
Yeah.
And also it's produced with low carbon concrete.
Yeah.
And it also has the workability of changing the design according to each project. So it's also an advantage.
Yeah, exactly. And when you use it for the scour protection, do you use completely instead of the rock, or you use it as a mixture with the rock?
So we can do both. I mean, partial or total replacement of the scour protection.
And for the US, did you use it partial or entirely instead of the rock?
So in the US project, it's a pilot project to test and compare between the rocks and the drop locks. So it was drop lock by itself without the rocks, and we compared it to rock armor.
Yeah. Thank you for your answer.
I wanted to add one thing, because you have to consider when you want to use natural rocks, we have to consider two things. The first is that normally these rocks that we use are from quarries.
Yeah.
It's not used to be the normal, the typical type of rock of the area where are you going to work. For example, in Fuerteventura, you need volcanic rocks. You don't have quarries from volcanic rocks with the same type of rock that we have undersea.
Yeah.
And the problem is that if you introduce a different type of rock, maybe you remove that other species growing that are not the normal species in the area. And maybe you can introduce a different habitat composition. and maybe you don't get the result that you want. In this case, in our practice, we get the same composition of species that the area with the concrete blocks. But if we introduce another type of rock with silex, for example, maybe we don't get the same results because maybe this type of rock is in favor of two other species.
Yeah, exactly. Thank you.
You're welcome.
Thank you, Patol. Continuing with the pricing, we have another question from our colleague, Charlotte Müller. Charlotte, would you like to ask your question?
You need to unmute too. Are you muted? Hi everyone. Thanks so much for the presentation, guys. It was really great. I just had a quick question about the average price per kilometer and how transferable this would be to a longer cable that's many more kilometers than the one this was applied to. And if you have a certain price estimate per kilometer that you already know, or if this is really hard to say because the local context is so dependent on it.
You ask for pricing for this type of practice?
Maybe not this specific, but an estimate of how much per kilometer applying this would take.
Now I'm working to have a standard price because it's not really easy. This practice was an urgent practice because we have a problem during the building phase. We have to find something new. We have to work really faster, and the prices were higher. Okay, we are managing now about that because we want to have a standard prices to consider in our standard projects. We don't have now actually an standard price. We are analyzing the market, considering all options that we have to produce in local with different producers. And we are managing about that because we don't have a standard price now. And for projects, it's complicated because all projects are different. You have to take project by project because in all projects you have different needs to protect the cable. Sometimes you have more sand, sometimes you have more rocks. We try to avoid rocks, but it depends because sometimes you are not able to avoid the rocky areas. It depends the prices.
Okay, I think I'm just wondering, in general, it's fine that you don't have the price, and that's totally understandable, but would this be affordable to do at a longer distance in kilometers and in other settings is the main question.
We are considering, we are studying. Okay. We are studying now, maybe in the future, and actually I'm working in this specific way, but we have a standard price.
Okay, that's great. Thanks so much.
You're welcome.
For us, it basically depends on the project, like he says, on the developers, on the manufacturing. All of that has large effect on the costing, but it's scalable. I mean, the bigger the project, the lower the cost is. So the more you do, and it's competitive price with standard concrete.
Okay, great. Thank you.
Thank you, Charlotte. I believe that we have one more follow-up question from the previous question from my colleague, Liam. Liam, would you like to ask the question yourself?
Yeah, sorry, so many questions keep popping up in my head. I find this discussion really interesting, especially Roberto, your answer about how if you add rocks from a quarry far away to the sea, it can maybe non-native species will have an advantage or similar. Does that mean that concrete as a substrate, when you add it to the sea, is neutral for all species?
I think that no. The typical concrete, if you see in harbors, the typical concrete blocks, big blocks, these concrete blocks don't have marine life because concrete finally don't offer the best substrate for marine life. In this case, with the practice of concrete, we get really nice results. It's amazing. From my side, I think that it's really amazing, this practice. But I think that we can say that this neutral substrate for colonize. I think that we have colonized case by case because in some areas, maybe another type of substrate could work better. Some companies are working with another type of substrate like carbonato, calcium carbonate. I don't know the English name. I have to find it.
Calcium carbonate, I think.
But some companies are working with 3D prints, 3D prints to produce this type of substrate, but actually is a really early stage, and we need to analyze more ties. I think that we have to analyze case by case.
Thank you, Roberto. Liam, do you have like another question from Yaeli, right? Or like Yaeli, you can also react to this one.
I mean, compared to standard concrete can also be colonized, but it also depends on species composition. Is it only invasive species? Is biodiversity high enough? So it could be covered, but it could be covered with only one species. So compared to that, what we do is actually offer the different texture and niches for the different organisms to colonize. By that, we're increasing the variability for all different organisms to colonize on the same type of structure. And yeah, that's it.
Okay, thanks. Can I go to my next question, Denise?
You may.
Thanks. So you said that the concrete, Eli, you said that the concrete can last up to 50 years. So my question would be then, what would happen after that period? What if, for example, a really, really valuable coral reef is developed, and this is a protected coral reef, and then it needs to be removed, because then maybe there would be legal issues? That's one question. And then also, what would happen from the grid operator point of view if the cable was obsolete? Would the cable be removed and the structure be left? So those are my questions. And then I have one more question. I'm really sorry to do this. Can this also be applied in non-rocky habitats? Can it be used, for example, in sandy banks or other habitats worldwide? Thank you.
Okay.
Really good
So
questions.
basically, 50 years is the minimum durability. It does last longer. But it also depends on the project lifetime, because we don't determine the project lifetime. So like Natural England report says that ECOncrete might not even need to be decommissioned. So it could stay because it is creating the habitat itself. If it will be removed, so basically it depends on the project and not on us. But marine life will return to that area. It will take time. There will be a succession phase, but it could return if it has where to settle. Regarding the different placement of our technology, it can be placed on sandy bottoms where cables are. So basically not only rocky areas.
In case if we have to remove a cable, it depends on our governments, because finally they decide if we have to take out or not. And actually, we are analyzing two cases. We have to remove the cables. You have to analyze not only when you develop a valuable ecosystem, because when you have to to remove the cable, you have to analyze all the impacts, and maybe you have more impact if you remove that you don't remove. And you have to consider, for example, in some areas, in some cables, we see that if we left the cable on the water, maybe we have an impact. But if we take out some specific areas of the cable, some small fragments of the cable, if we take out these fragments, we can offer or we can improve the quality of the marine life. We have to analyze case by case, and we have to talk with our governments what they consider what is the better way. But if we have a valuable ecosystem, finally the best way is to leave everything underwater, because we improve the quality. And if we remove, finally you destroy, and maybe you in 50 years you can have gorgonias and a lot of animals that need a lot of time to grow. And if we destroy it, finally we lose all the value that we get offered to the project at the first stage.
Thank you both. Thank you, Liam, for your question. Following up with the idea of replicating this in a sandy environment, I believe that Quentin Bordos, you have a follow-up question. I think that this was partly already answered, but would you like to elaborate a little bit more on what's the question that you have?
Yes, sure. So in a sandy environment, we build a lot of wind farms in these areas because it's a nice bottom to build stuff on. We know that the structures that we build there now increase biodiversity and biomass, but it is a change of the environment. So what we bring is actually a different type of species that were not there necessarily before. I know that there's been a few studies that tell us how close different reefs environments can be to each other to have a positive influence. So 1 + 1 = 3 in a way. I'm wondering now with these matrices, so here I'm not talking about the drop blocks, but the matrices, would one single mattress on a sandy bottom will have a positive impact? Is it large enough for that, or do you need then a larger structure to make a sustainable reef system?
I mean, basically, the mattress can be also fit by size. Like in Red Eléctrica project, just the units were placed and not the entire mattress. The entire mattress will create habitat, will have a positive influence. Of course, the bigger the structure is, the bigger habitat and ecosystem that you're providing. And it will have a larger halo effect around the structure as well. So when you place one mattress, it has an effect, but as you said, when you put two of them together, they can have a greater effect, and also the surrounding of the infrastructure itself will also be influenced by it. It can increase the biological debris and organic matter, and also provide a lot of nutrients for sandy bottom organisms. So basically, the more you put, the larger effect you will have. But also one mattress can definitely create an ecosystem.
Normally, when you work in sandy environments, we have another option to protect the cables. Sometimes you have problems and you need to use their remedial protections. And in these cases is when you have to use the matrices or something similar. As Yaeli says, it depends, the reef effect, it depends on the height of the size of the infrastructure. But it's not only that you create a reef habitat, that we have to consider that these small reefs could be biodiversity corridors, because they allow to different connection, ecology connection to different areas that promote the translation of different species that can move the larvae and grow in other areas. It's important. But another thing that I have to add, okay, because in cable protections, if we put a big infrastructure, we are doing an artificial reef. Artificial reef used to attract divers, fishermen, and finally, you improve the risk for your cables. And you have to manage very well what are you doing, because you want more fishermen on your cable? No, we want to protect the cable. And you have to manage very well the risk and how we can work with this type of solutions to improve the marine life. And in sandy lives, if we have sandy bottoms with sandy, we have to maintain sandy bottoms. We don't have to change the sea bottom. We have to manage that, to offer that the same type of rock or sand, the different types of sea bottoms are in the same areas. Because if we change everything, finally we are trying to change all around the sea bottoms, and finally we can offer this group solution for marine life.
Thank you very much, Roberto. I have another question in terms of replicability, and monitoring as well. Roberto, specifically for Red Eléctrica, like how long you show the images that are quite impressive, that you have already some initial results after 10 months, and this is really exciting. Now, how long and how often will you be monitoring those results, and until when you will have certainty that this is actually a practice that you would like to replicate in other sites?
Well, actually, we are monitoring every 6 months the concrete blocks. Okay, the last was 1 week ago, 2 weeks ago. I can see the last pictures, but we monitor every 6 months. It depends, because we have to do some environmental programs, surveillance programs, for follow how the cables impact on the sea. We are analyzing this, and we have these programs that to follow and surveillance. But we don't know. I think that in this case was 4 years, could be. In this case, a specific case, and we consider to use this type of solution for the projects. Actually, we have 3 projects in construction steps. We are analyzing this type of solution for some specific areas when we have fed reef areas, and we consider that could be a really good option to offer the natural recovery to, but maybe we consider another type of solutions like more active restorations.
Perfect. And from your side, Yaeli, how can this solution be replicated in other kind of contexts, for example, that are not only the corridors, but maybe offshore wind farms or any other kind of type of infrastructure at sea? Do you have any concrete examples or any plans to actually replicate these solutions?
Yes, so the marine mattress is in an offshore wind farm in the US as a cable protection on a sandy bottom. The drop locks can be for scour protection, but also for cable stabilization systems. So basically, we aim to use the same solutions where applicable, but we have many different solutions for coastline and shoreline protection. So for each different solution, we provide a solution with our technology.
Thank you, Yaeli. I think that we have another question from our colleague, Kendall. Kendall, would you like to ask your question?
Hi. Yes, just to bring it back a bit to the marine species aspect, I was just wondering what were the main species of concern in the project area, or which were the ones that were considered the most when you were laying the subsea cable? Just if you have any info about that, I'm just curious. If you can give information on that.
No, I mean, Roberto knows more about the information on that specific location. But in our project usually, or the client or the developer or even the country or the state have target species that then we try to accumulate our solution to accumulate those species. But otherwise, we really believe in enhancing biodiversity as a whole and not targeting only a few species and accommodating them. But for this specific project, Roberto definitely knows more.
I have one more question.
Every project is really different. You have to consider the different types of species and the specific area, because you can only think in a visual like Lanzarote and Fuerteventura. You have to focus in this area and analyze what you have in the area around your action. In this case, in the common area, one of the species that is more visual for the size is Lobophora variegata, that is really, really high. And we have another one now, I think it's Asparagopsis. Now I don't remember all the names.
Asparagopsis taxiformis, the seaweed.
Sorry?
You said Asparagopsis taxiformis, the seaweed, or? Yeah. Oh, okay. Sorry to interrupt.
Because in some areas you have typical species that you can find in other areas of Europe, but Canary Islands are really specific with the macroalgae that they have there in Macaronasian area and are really different. You have to consider and analyze it in detail. But finally, you have to analyze what you have in the natural area and what you have in your action area, because you have to compare. Actually, we are working with ECOncrete to prepare a new protocol to monitorize how they're growing. Because imagine we did this practice like urgent action, and we decide something quickly to do something that can improve our results. And at the first time, we will consider a specific monitoring to take more time, but we are working in that to improve the knowledge and analyze in a better way what the species are growing in concrete blocks. With pictures, we see that we have a similar species composition that the natural areas.
Okay, that makes. Sorry, I was muted. That makes sense. I appreciate you answering the question. I was wondering if there were any specific mitigation measures during this process. I know you said it was more of an area-wide focus, not a species-based focus, but just curious about any specific mitigation practices that you found effective during that process, or maybe afterwards as well.
Yes, we can consider that. And it's important to consider all species. All species, not only macroalgae that are growing, all the species that are using the blocks because they have used our habitats, and we can do more things. We are continuing to do more things to analyze and understand better how it works. And if finally the results that we are seeing, it's to confirm, because if we don't have data, we need data to compare and to analyze it. It's really working. But in visual, as you see in the pictures, it's amazing. Results are amazing. You can see how the concrete blocks are mimicked in the natural area, and it's really complicated to detect. If you don't know that these blocks are in this area, you are not able to detect it. But we need to analyze in more detail how all the species, not only macroalgae, because finally macroalgae used to have a faster growth, but we need to analyze how species, crabs, gastropods, or other animals are using.
Thank you, Roberto. One more thing, well, actually a few more. Are there any other questions? You are still, we still have a little bit of time. If you have any, please raise your hands or post it in the chat. Otherwise, I would like to ask you both, actually, how can we know more about this practice? Is this somewhere in the website, in the Red Eléctrica website? Can we share the slides with the audience? How can we actually know more about this solution?
We have in Red Eléctrica, we have in our webpage, we have information about the project. We have the information in RGA Awards, or I don't remember the name of the award, sorry, but we share all this information. You can see the video in RGA. I think that a lot of information are able. I think that in ECOncrete webpage we have as well information in LinkedIn. We are sharing a lot of information about this project, and we want to continue do it, because I think that if we share with everyone this type of practice, everyone can learn and everyone can use their mind to find a new way to use it, and we can work to improve more our marine lives.
In our website, there's a lot of information and case studies, but also a lot of scientific papers that we write on specific projects that we do monitor periodically to test the different solutions that we provided. And all other solutions are also available on our website and LinkedIn, of course.
Excellent. So thank you so much, Roberto, Yaeli. This was extremely interesting. I'm sure that this webinar is going to be further viewed in our websites. As we mentioned before, this has been recorded. So it's going to be, the recording is going to be available in both RGI and Ocean websites in case you want to share the link with your colleagues if they didn't have the chance to join us today, together with the slides as well and further information. Thank you so much for your time, for your presentations. And for the rest of the audience, thank you so much for joining. Please don't forget to subscribe to the RGI newsletter in case you're interested in joining more of these events. Specifically, we also have a section for offshore related events that my colleagues are posting right now in the website. Thank you very much for your attention, and we wish you a lovely rest of the day.
Thank you very much.
Thank you very much.
Thank you very much. It's been a very great presentation. So thank you very much, RGI, for the opportunity to share this information. It's a pleasure for Red Eléctrica.
Thank you very much, Luis. It was a pleasure. Thank you, everyone.